Sorry about the delay last week. Camera had some issues, so now I have a new one. And I can continue with what we were doing. Last week's was supposed to be about nomenclature, so I'm going to describe briefly on this. And then, following video, I will be talking about Lewis structures and bond angle structures. And I'll go over the rules today, good pros and cons to each, and so on and so forth. So, which is better with the nomenclature between IUPAC and the common names? IUPAC is relatively new. However, IUPAC has various benefits. The common name has some benefits, but the common name is older, hence why it's called the common name. IUPAC, like I said, is newer. IUPAC stands for the International Union of Pure and Applied Chemists. So, what are the pros and cons? Well, IUPAC, some pros are, you're given a molecule and you can draw it right out, explain it, know what's there, you're done. Okay. Methaldehyde. Also, formaldehyde in the common name. Here are two right here. Same thing, different names. So I'll draw out methaldehyde. So by looking at the rules of IUPAC, there's a carbon chain, which is the most essential. The longest chain, when we get to bond angle structure and everything, or line angle structure, that will be very helpful, but the carbon chain is very important. So usually you'll go from 1 to 10, but some professors might want 1 to 20, and so forth. But 1 to 10 starts with meth and goes up to dec. You can look these up on the computer. Same with the groups. There's methyl groups and there's butyl. But you can look up, the ones in between online. And same with the, say if there's 2 methyl groups, it's dimethyl. If there's 3, there's tri. If there's 4, there's tetra. And so on and so forth. This is all stuff you can look up as all the rules. They're quite simple. Self-explanatory. At first you might not, want to go by them, but once you learn it, it's a lot easier than trying to memorize common names and taking a wild guess, trying to guess something. So, methaldehyde. We have a meth, and there's an aldehyde group, functional group. So, we have 1 carbon for meth, and then we gotta make the bond happy. But we have to look at the functional group, which has an oxygen, which is double bonded to the carbon, which looks like a ketone. The only, like I said, the only difference from last week's video is there's an H, and then there's also another H here to make a carbon happy. I'll go over some hybridization really fast next, but that's another thing you should have learned from general chemistry is hybridization, because that's very important with carbons in organic chemistry. So anyway, so formaldehyde. What do we have here? An aldehyde. Form. What is form? I don't know. Why is it called formaldehyde? Because that's just the name it was given. The IUPAC name actually describes the molecule. However, if you're looking in the shop for, let's say, your science class, even though formaldehyde is really no longer used, there's newer chemical, we're going to look at methaldehyde or you're going to look at formaldehyde. Oh, I know about formaldehyde. Methaldehyde, I really don't know. So a pro to the common names are, a lot of people know the common name. The IUPAC name, people are still scratching their head. However, IUPAC is making some good breakthroughs and people are starting to pick up and it's starting to be used somewhat, but I believe the common names will be around a lot longer still. They've been around for a long time. But anyway, so that's formaldehyde. Prime example there. Form does not express anything about this. Only the aldehyde. The aldehyde group. When it gets to bigger molecules, like resveratrol, how do you know what to draw? That's a name. It's trans. There's a trans in front, so you know it's a trans. We don't know. That's it. You can differ between a cis and a trans. But you can't do anything else. So that's one problem there. A pro and a con, just expressing each of them. However, you get to resveratrol, like I just told you about. You put that in an IUPAC name, you're probably going to take out my whole board. I mean, I'm over-exaggerating, but it's a very big name, where resveratrol Sorry, my marker's kind of messed up. That's that small word compared to a gigantic IUPAC name. Because it has 2 benzene rings, it has a double bond, it goes on and on. But anyway, so that's that. But what I'm explaining about common names is, for example, ether. Ether was discovered in around the 1200s. So you have a molecule that, or ether's been around for quite a while, and IUPAC's relatively new. There's a ton of ethers under the IUPAC title. Diethyl ether, methyl ether is a functional group. That's how vast it is. Common name, oh, ether. Okay, we know it's used as an anesthetic, but the real name for that ether is diethyl ether. So if you're drawing that out, you know, you have 2 ethyl groups. Here, 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 and here. Diethyl, like here it is by the rules. Ethyl. Ether is the functional group. So that's that. Ether can be used for a variety of things. It's used in a lot of reactions, a lot of chemical setups. It can boil in your hand. Its boiling point is 98 degrees Fahrenheit. I don't know what that is in centigrade, so I should. But I'm so used to Fahrenheit because, you know, that's what we do in America. But anyway, so that's that. Alright, so then we look at sulfuric acid and acetone. Those are common names. Oh, let's look at sulfuric acid. You know, there's an acid. But that's about it. Sulfuric. Oh, IUPAC. There's no such thing as sulfuric. Okay. So then we go on to, here's another example. Ethylene. Oh. Yep, I have these 2 mixed up. This is actually the common name. This is actually the common name. See if you pick that out. But anyway, so that's that. And then there's like cyclohex and all. They can draw all of these out. These you can only draw partially out. You can't draw everything out either. Oh. Oh, literally. Oh, that's all you know. So that's that. Alright, so let's look at, there's new and old IUPAC names. So on top of common names, there's new and then there's old IUPAC, which can be kind of a pain. So you have 2 butene. That's old IUPAC. Older name. Now they're changing it to butene. I prefer to use the older way. The newer way is supposedly the way to go, but it's really up to you. It's easier supposedly to describe the molecule out that way. But like I said, that's all up to you. So pros and cons. They both have pros and cons. IUPAC, though, I believe is the right choice because you can understand what you're using. Understand the molecule, understand the setup. And if you want a better grade on your test, you should use IUPAC. Common names are iffy. Now, some common names are used. Some pieces. For example, iso, sec, and tert. These make it a little easier, I will say. So you say you're drawing something. Okay, let's draw something with an iso. Let's draw isopropyl. So say we draw a ring. Cyclohexane. And add that branch. There's an isopropyl group. It's a lot easier to draw than trying to get, oh, let's count the carbons here. We have 1, 2, okay, ethyl, one with a 1-methyl on it. It's just a pain. Isopropyl is a lot easier than drawing that out. Now, okay, so that's another one. Secondary is another one. And then tertiary. Tertiary is used a lot. Tert-butyl, you will hear that a lot. That's a common name that's used a lot in organic chemistry still to this day. And then the pain of the Lewis structures right here. A strong example here of a tert-butyl. Tertiary. Look at this. Don't mind the curves here, but I'm just showing you how it works here. Tert-butyl. This isn't tert-butyl, but tertiary. This is a tertiary right here. Tert-butyl literally just has 4 carbons in it. There's tert-butyl. But anyway. But when you get into stability, later on, we'll discuss that in the future. Stability, you'll be using degrees 1, 2, and 3, and then you'll be using the ring, what could be benzene, or whatever the ring may be. When you're dealing with electrons jumping, you'll be using like tert, sec, and primary. Well, it's primary or it uses primary, but that's another problem. See, overlap. So that's that. Common names still are somewhat used, like vinyl. That's another one. You got, like I said, it's used a lot, but that's that. And then IUPAC is used a lot more, kind of pulling the transition over. Although the common names are fun, IUPAC names get the job done. If you have any questions, feel free to comment below on my feed. My next video I will be publishing it pretty soon, within a couple hours maybe, or a couple days. That will be on Lewis structures and line angle. Thank you.